It's your boy Master929 and welcome to my YouTube channel. So today we are going to prove their identities. So now let's jump straight to number one. So now here first thing that we have to do here is to choose the side that is complex. So here the side that is complex is this side, meaning we are going to prove that this side is equal to what? Tan theta, and this side is what? Is left hand side. Okay, so and remember, tan theta is equals to what? Is equals to sine theta divided by cos theta, meaning at our numerator side here we have to be left with sine theta, and at the denominator side we have to be left with what? With cos theta. So now back to our expression. So now here at the numerator side, what can we do? We can take out the common factor of what? Of sine theta. So now let's take out the common factor of sine theta. So we're going to be left with sine theta into 1 minus cos theta, then all divided by, okay, now let's jump to our denominator side. So at our denominator side, one can know that we have the square identity inside the bracket, and we know that this is equals to what? This is equals to cos squared theta. So now we are going to be left with cos theta minus this minus is this one, and then this one is equals to what? Cos squared theta. It's a square identity, this one. Then from there, what are we going to do? So at our numerator side, what can we do? There's nothing that we can do at our numerator. So now let's jump to the denominator side. So at the denominator side, you can see that we can take out the common factor of cos theta. So now let's take out the common factor of sine theta. So we're going to be left with this, all divided by cos theta as a common factor, 1 minus cos theta. You see, so now one can know that this one will cancel this one, so we'll be left with what? Sine theta all divided by cos theta. You see, then this is this, and we know that this is equals to what? Tan theta. So now you're going to be left with what? Tan theta. You see, therefore we can conclude that left hand side is equals to what? The right hand side. Then we're done. So now let's jump to example 2. So first thing that we have to do here is to choose the side that is complex. So now you can see that the side that is complex is what? Is left hand side, meaning we are going to prove that this side is equal to what? 2 tan p, and we know that 2 tan p can be written as 2 sine p all divided by cos p. Remember, sine p all divided by cos p is equal to what? Tan p, and we multiply by 2. You see, so now this tells us that at this side we at final we have to be left with what? With one fraction. You can see now we have two fractions here. So how are we going to eliminate one fraction so that we can be left with one fraction? So what we have to do here is to subtract these fractions. And how are we going to do that? So first thing that you have to do when you subtract the fractions is that you have to make sure that the denominators are the same. And as you can see now, our denominators are not the same because the expressions there are not the same. So how are we going to make them to be the same? So now this is what you are going to do. You are going to say cos p all divided by 1 minus sine p. This one is this fraction. So you are going to multiply this fraction, the first fraction, with the denominator of the second fraction. So now we are going to multiply with 1 plus sine p. Now let's erase this one. Let's write it here. 2 sine p cos p. Then here going to multiply with sine p. Remember, this is 1. You see? Then from there we going to write this minus, then introduce this fraction cos p all divided by 1 plus sine p multiply by what? Multiply by this denominator of the first fraction, which is 1 minus sine p, all divided by 1 minus sine p. You see? Then from there we do what? We eliminate what? The bracket. So how are we going to do that? So now we are going to take this cos p and multiply each and every term that is in the second bracket. So we are going to be left with cos p plus cos p sine p, all divided by what? 1 minus sine p, 1 plus sine p, then minus. This minus is this one. Then we are going to take this cos p and multiply each and every term that is in this bracket. So we are going to be left with cos p minus cos p multiplied by sine p, all divided by 1 minus sine p multiplied by 1 plus sine p. You see? So now we can say that our denominator are the same, because we have 1 minus sine p all multiplied by 1 plus sine p, and even same as this fraction. So now what we can do is that we can write only one denominator and add the numerators. So now we are going to be left with cos p plus cos p sine p. This one is for this one. Then we are going to subtract it with what? With this expression. So we are going to put this expression inside the bracket, 1 minus cos p sine p. See? Then we are going to divide this with what? With only one denominator, because the denominators are the same for these two fractions. So we're going to be left with this sine p. You see? So now let's remove the bracket at the numerator side. So now you're going to be left with cos p plus cos p sine p minus cos p plus positive multiplied by negative multiplied by negative is positive, and cos p sine p, and all divided by 1 minus sine p multiplied by 1 plus sine p. You see? So now back to the numerator side. So at the numerator side, you can see that we have like terms. We can take cos p and minus it with what? With cos p. So we're going to be left with what? Cos p multiplied by sine p plus cos p plus sine p. You see? Then we're going to be left with 2 cos p sine p. Why? Cos p minus cos p is 0. Cos p multiplied by sine p plus cos p multiplied by sine p is 2 cos p sine p. You see? Then all divided by what? 1 minus sine p, 1 plus sine p. You see? So now there's nothing that we can do at the numerator side, but there's something that we can do at the denominator side. Remember, at the numerator side we have to be left with what? With sine p, or with 2 sine p. Then at the denominator side we have to be left with only cos p. You see? So now here we have to make sure that we eliminate this cos p. We already have 2 sine p. So at the numerator side, at the denominator side, we have to be left with what? Only cos p. So now let's try to remove this bracket. So we're going to be left with let's continue here. So we are going to be left with 2 cos p sine p, all divided by 1 multiplied by 1 is 1. 1 multiplied by sine p is positive sine p. Negative sine p multiplied by 1 is negative sine p. Negative sine p multiplied by positive sine p is what? Is negative sine squared p. So you can see that at the denominator side we have what? The like terms. So the like terms will subtract each other. So you're going to be left with 2 cos p sine p, all divided by 1 minus sine 2p. So now one can know that this is a trig identity. Which trig identity? The square identity. So we know that this is equals to what? Cos squared p. So now we are going to be left with 2 cos p sine p, all divided by what? Cos squared p. You see? So now remember, at the numerator side we want to be left with 2 sine p, and at the denominator side we have to be left with cos p. So now you can see that this one can divide this one. You see? So we are going to be left with what? 2 sine p all divided by cos p. Why? Cos p divided by cos squared p is equals to what? It's equals to 1 over cos p. Because here we're going to be left with 1, and here we're going to be left with what? With cos p. So now this is equals to this, and we know that this is equals to what? To this. So now we're going to say 2 tan p, because this part is equals to tan p, and we have these 2, so these 2 will multiply the tan, so we're going to be left with this side. And remember, this side, this one is what is our right hand side for our problem. So now we can conclude that LH side or left hand side is equals to what? A right hand side. So now let's jump to example 3. So even here, the first thing that we have to do is to choose the side that is complex. So the side that is complex is this side, which is what? Left hand side. Meaning that we are going to deal with the left hand side. We are going to prove that this expression at the left hand side is equal to the expression at the right hand side. So now one can know that at the right hand side, on the numerator side, we have what? We have tan a. And this tan a can be written as what? Sine a divided by cos a, multiplied by, inside the bracket we have a trig identity, which is square identity. And we know that 1 minus sine squared a is equal to what? Cos squared a minus cos squared a, all divided by what? Sine squared a minus cos squared a. Then next step, here we can know that cos squared a will divide cos a. Then we will be left with sine a multiplied by cos a minus cos squared a, all divided by sine squared a minus cos squared a. See? So now remember, we want to be at the numerator side, we want to be left with what? With cos a. And at the denominator side, we want to be left with what? Sine a plus cos a. So now how are we going to do that, or how are we going to get here from here? So now one can know that we can factorize the numerator side, even the denominator side. So in other words, we are going to factorize the whole fraction. So at the denominator side, we can take out the common factor of cos a. So if you take out the common factor of cos a, we'll be left with this, sine a minus cos a, all divided by, at the denominator side we have the difference of 2 squares. So this means if you factorize this thing, we'll be left with sine a minus cos a multiplied by sine a plus cos a. This is a difference of 2 squares, and when we factorize it, we will be left with something like this. And then from there, one can know that at the numerator side we have sine a minus cos a, and even at the denominator side we have sine a minus cos a. Therefore this one will divide with this one, so we'll be left with 1 and 1. In other words, this one will cancel this one, then we'll be left with what? With cos a, all divided by sine a plus cos a, and this is this. Therefore we can conclude that left hand side is equal to the right hand side.